Hi, good morning, good afternoon, good evening, wherever you may be. Welcome for today's webinar hosted by ASE Calcitech. Uh, my name is Midun. I'm from the marketing team at ASE. I'm just we're waiting for a few more folks to join in. I see a couple of more folks joining in the minute. So just give it a minute or two, and then we will start the webinar. So, as you all know, we are going to discuss about detecting delays in process bus and scanning IEC61850 sample value streams from the network. This webinar will delve deep into the complexities of station bus and process bus network delays and the nuances of scanning SV streams. A couple of hygiene points before we start. This is going to be a 45-minute webinar and will be followed by a 5 to 10-minute Q&A session. Please note that this is going to be a listen only webinar. If you would like to ask any question or have any query, feel free to ask in the chat screen. Also, if you have any logistic issues with regards to the voice or the video, you can just ping directly on the same chat on the AC Calcitech marketing chat window, or maybe you can raise a hand as well through the GoToWebinar app. I will be consolidating all the questions and have it answered towards the end of the webinar. If in case we are not able to answer every question, we will get in touch with you personally and try to address all the queries. Of course, a recording of this webinar will be sent to all the attendees here after 24 to 48 hours. We will also be sending another email on the webinar participation e-certificate. This will be sent again after a day or two. All right, I think we have quite a few folks who have joined in. Now, without further ado, let me introduce the host for today's session, Vinu S. Warrior. Vinu has been with Calcitech for over 25 years now and is the VP and head of AAC products. His chief interests include design and implementation of protocol solutions for the power industry, consulting, and training in protocols like IEC 61850, DNP3, IEC 101, 104, and DLMS, COSEM, etc., as well as participating in standard bodies like IEC TC57, Working Group 10, Bureau of India Standards, and many more. He, of course, has authored a lot of white papers and presented in various events across the world, most recently in PAC and today, of course, he's going to discuss about detecting network delays and scanning IEC61850 SVs from the network. So yeah, so over to you, Vinu.
Yeah. Thank you. Thank you very much for the introduction and good morning, folks. Uh, so in this webinar, we will be taking a deep dive into some features of the BNET. The BNET was a accessory to our ASE61850 test set, which was launched quite early this year, and we have already had a few demos and webinars earlier on the basic functionality that it supports, that is primarily on publishing and subscribing sampled values into the process bus. But since then, we have had some more developments, and we have very recently launched the next version of the ASE61850 test set, which is available on the website now. And in this new version, we have added some more features specifically on the BNET. That is, one is we now support the IEC61869 sampled values. Previously, in the original launch, the product only supported 61850-9-2 LE, but now we support 61869 as well. And another feature that we have added in this release is the ability to scan 61850 sampled values from the network. Basically means you can just sniff the network and detect and load those sampled values and start monitoring them. So this would be the prime features that we are discussing today. Detecting network delays, that is a side use case, a small use case that we thought we'll also incorporate into this demo. So this is the agenda. I'll just talk to you for a few minutes about ASE61850, the suite of tools that we offer, and specifically, of course, the BNET. And then we will move on to the demonstrations. We'll be showing you publishing and subscribing sampled values with the test set and the BNET. And this now includes not just the 9-2 LE, but also the 61869-9 sampled value packets. We will check how we can use the BNET to test your networks. These are some basically a way to test your network segments. I will be using a switch, a local switch to which I'll be connecting a loopback. That means I'll be publishing and subscribing to and from the same switch. But in reality, you would probably have a more extensive network than this. You might have multiple segments connected through some trunk lines. So if you want to understand what is the impact of that, one way to do it is to loop back the connection from both ends of the network and then measure those delays. This will also be a way to verify that your VLAN configurations are working because the sample values are configured with VLANs. So both the publisher and the subscriber are looking for a specific VLAN tag. So if your network is not configured properly, you might be able to detect those kind of issues as well. And we will finally wind up with a demo of our scan for sample values feature, where we will snip the network for the sample value streams and we'll start monitoring. So that's the agenda for today's webinar. About us, Applied Systems Engineering is basically a subsidiary of Calcitech. Calcitech was founded in 1998. Applied Systems Engineering in the US is actually earlier. It was founded in 1989, but Calcitech acquired ASE in 2015, and since then it has been our 100% owned subsidiary. And the ASE suite, 61850 suite of products, these are the tools that we supply. These are the tools that we will demonstrate to you. One is, of course, the SCL Manager, which is our leading independent third-party system configuration tool and system specification tool. And then there is a 61850 Test Set, which can act as a server, it can act as client, it can even act as a monitor mode. And it has various use cases that we have demonstrated over many webinars in the past. So I urge you to, if you're interested, to go and look up our webinar recordings or other informative videos on our website. But primarily the focus of this webinar is on the device at the bottom, the BNET. The BNET is a small handheld accessory. The picture doesn't do it justice. You can estimate its size from the size of those Ethernet ports that you see on it. It is a handheld device. It's a very portable device that you carry around along with your laptop. And you can use it to connect to up to 4 networks. It has 4 gigabit ports. It has got a solid state disk drive. It has got PTP support. In short, it has got everything that you need to be able to connect to the process bus and publish and subscribe sample values with the features that you may not usually find on your Windows laptop. Hence this accessory. So now we can get along with the demonstration for this webinar. One is testing VLANs. How are we going to verify VLAN networks? Well, essentially, we have a feature on the BNET that you can specify different interfaces for publishing and subscribing. This is not a very normal use case. When you go to a substation, there will be a process bus. You will connect to that, and whichever interface you connect to the process bus is what you use. You publish into it, or you subscribe into it, subscribe from it, or you do both, depending on what is the use case that you're trying to test. But we do have the option to specify different interfaces for the publishing and subscribing, which is something that we can use to test the speed and latency of your network, of your switches, of your network segments. And the same thing works for your measuring the network delays. So we are going to do this in this demonstration. We'll do some loop backs, and we'll do a loop back with a cable, and then we will do it through the switch and see what is the difference. And finally, we come to the scanning. So in scanning, what we are going to show you is that we will not load any SCL file. The test set will be working without the SCD. It will simply sniff the network, detect sampled value streams, both 9-2 LE as well as 61869 packets, and then you can load those. So the mechanism we have in our test set is that we can create an SCL file for those scanned SVs, which you can save for a future reference. And you can actually even play back the same. You can use those files to create the exact same sample values that you detected and play them back into the network if you want to do that as well. So in the demo setup, the first thing that I'm going to do is I'm going to use a BNET. I'm going to connect to this BNET from my laptop. So I have a separate network for the management. That means I'm connecting one of the ports on the BNET to the management network. That's where I'm connected on my laptop. And I'm using two different ports on the BNET, which I will be using as a publisher and subscriber. And there are two use cases here. One is I'll simply loop it back with a cable. And in the second part of the demo, I will connect them to the process bus so that they're going through the network switch, which has whatever configuration it has. So this is, as I explained earlier, it's a very simple example where you're just going through a switch, but in reality, your publisher may be on one switch and your subscriber may be on another switch connected together through a complicated network. So if you do have such a network, you can still do the same thing. You connect one end to one port of the BNET and connect the other port of the BNET to the other end of this network segment, and you do exactly the same thing. So this is going to be the first part of the demo. So I will step out of this presentation and I'll quickly show you the configuration. I have created this configuration on SCL Manager. So what I've done is I've created a simple project in which I've simply created two IEDs. This is something that you can do with SCL Manager. You can create your own IEDs. The IEDs are extremely simple. Just for the sake of this demonstration, essentially it has a access point and it has got a logical device and it's got a bunch of PCTR and TVTR logical nodes. This is what we expect. So I have two devices. One is the merging unit for the 9-2 LE standard, which has 8 channels of information, that is 4 current channels and 4 voltage channels. This is the standard. It's a fixed data set. So I have created the data set here, and this is the data set with all the current and voltage samples and their qualities. And I use this data set which I have associated with one sample value control block. This is a control block, and the data set has been associated here. This is where I've specified the data set. This is the sample value ID, and well, it is set to a sample rate of 80 samples, and that is basically sampling mode is samples per period. So that is samples per cycle, so 80 samples per cycle. And this is the network configuration. This is the multicast address to which we are publishing it. And you can see that I've configured the virtual LAN ID priority here. In the same way, I have a 61869 merging unit. The difference is that, as you know, 61869 supports a flexible data set. You can have different combinations of channels. And the maximal case, it can support up to 24 channels. So here you can see I have created 12 TCTRs and 12 DVTRs, so 12 current samples and 12 voltage samples. And I have added all of them into my data set that I call the 61869 data set. I have all the 24 channels of information that are specified here, and I have mapped it to a sample value control block. Here was associated the data set. As you can see, I specified the sample rate as 4800. That is because the sample mode as per 61869 is always specified as samples per second, not as samples per cycle. So it is configured according to that. You can see I specified the VLAN ID and priority, and these are all the data set elements. So I exported this SCD file, and I use this to load my publisher and subscriber. So I'll minimize this and I'll start my test set. All right. So as I explained, I have a single instance of the test set, and I can switch it to server mode. As you know, the test set supports the ability to work as a client in client mode using these buttons in the bottom, or as a monitor mode, or as a server mode. Now I'm going to use a server mode because I want to load the SCD file that I've created and use it to initialize those IEDs so that they can publish. In server mode, we support these two new features. That is, with the BNET, you have the ability to publish as well as subscribe. So to add the IEDs here, so one more thing you may notice is it says BNET disconnected. That is because there are a few properties you can use to configure this. In the properties, you have options where you can specify automatic connect of the BNET. So you can have an option to automatically scan for the BNET, which I have set to false. And you also have the option to automatically connect to the BNET, which I have set to false. And that is why it is disconnected. The reason is that in this demo, I'll be connecting, towards the end of the demo, I'll be connecting different instances to different BNETs. And at that point of time, I want to control which one gets connected where. Normally, if you set this to true, you don't have to do anything. When you launch the test set, it will scan the network, find the BNET, connect to it, and it will be initialized and ready by the time you start working with your configuration. That is the normal mode of operation. I have intentionally disabled this right now so that I can work with it individually. So now I can go ahead and go to BNET settings. Because it's not connected, it shows me the option. It helps me by remembering the last connection that I used. So this is the first BNET that I'm going to use. I'm going to connect to that. And this is the BNET administration panel where you can look at this communication interfaces. It's got 4 interfaces, uh, 1.121, 2.121, 3. And 4. These are the 4 interfaces that have been set up. And I've got the time setting here. So when it comes to time setting of the BNET, you would normally want to specify PTP master or an NTP master, and you would need to configure that here. In this case, I'm now working in a isolated LAN where I have a switch on my desktop and I'm connecting 2 machines and 2 VNets to it. And I have 2 switches, one for the management interface and one for the process bus interface. So it's an isolated network and I do not have a clock in the network. So right now I'm using a very rudimentary mechanism of setting the time. You can just use your computer and set the computer time to the VNet, which is now running slightly behind. So I'll just set the computer time again. All right. So I've set the computer time. You also have the option to modify firmware. So you can just browse and select a new firmware update package and apply it. But right now I'm done with the settings. This is the other part where you can specify the interfaces that you want to use for publishing and subscribing. So as I said, for this demonstration, I'm going to use 2 interfaces. Whenever this BNET publishes, it will publish on interface A. And whenever it subscribes, it will connect on interface B. So as you can see, my management connection, the star here, you can see the star mark. This is the management interface. Right now I'm connected on the 3rd interface, 3.121. This is what I use to connect to this BNET, which shows this interface as the management interface. And I'll be using this as the process bus. So I need to configure my system. How do you do that? You simply click on the plus button and you select the SCL file, you browse and pick up the file. I've already done that earlier. So the ASE test set saves all my configurations. So I have here the VNet webinar.scd and I have the IEDs. I have not configured any IP address in the SCL file because these are just merging units and they'll just be working on the L2 level. So all I need to do is just start these two and initialize. They are ready. Now, unlike our regular IEDs, uh, which start running as soon as they're started, if this IED had goose reports or any other data transfer available, those would have started running. But unlike that, for sampled values, we have a manual control. If you want to start publishing, you need to manually set it up. So you can open this, go to the Publisher tab, select your sampled values, and just drag and drop them. This initializes the sample value into the BNET, and we are now ready to start publishing. I'm going to loop back and subscribe to these streams in the same instance. So I'll just click here, drag it, drag. As you can see, this is one is the 9-2 LE and one is the 61869 data set. So now I need to make my connection, and as I showed you in my presentation, I'm going to go with system 1, where I'm simply going to loop back port A and B. My port C is connected to my management interface. So this is what I'm going to do. I'm just going to connect the cable. Just a mess of cables here right now. All right. So the cables are looped back. My switch shows that they're connected. And now I can start the subscriber. I just select the subscription and I say start. And it shows the start event. This does not mean that there is any status. Right now, if you look at this event, it just says monitoring has started. So far, there is nothing on the network. I'm going to go to the publisher and start publishing. Select both of them, click on publish, and you can see here two user events: the stream status publish start and the SAM sync value is set. So if you have seen some of our previous webinars, you would know that you can actually set the value of the time sync status. Right now it is set to not forced. That means you're not forcing any negative or positive value. It just shows you the actual value of the time sync status. This is not saying much right now because this is when you're connecting with the computer. When the computer is a source of time, it always says good, it always says local. But in any case, this is what I'm subscribing here, and as you can see here, you have a event. This was a monitoring start, and this is the stream start. The stream has started at this time, and the values are available. These are the values that is reading from the publisher. I can change some values here. I go to the publisher, I can just set up some arbitrary values. I'm just using some very dumb values. Please bear with me. I apply the values, and when I come back to my monitor, I can see the changes. One is the RMS values have changed from 0 to whatever I set. And there's also an angle threshold crossing because earlier there was no angle because the values were 0. And now I've not set any value, so they're still 0. But earlier there was no reference. Now the values are 0. So right now I'm running in loopback mode, and we also show you some statistics. This is the minimum, maximum, and average. So if you focus on the average value, you can see that in loopback. Oh, I'm sorry. What I did right now is I've connected it through the switch. So these are the values you are seeing, which means let me just show you the slide again. So what I've done now is actually step 2. I have two cables. Instead of looping them back, I ended up connecting them to the switch. This is the configuration that's running now. And you can see that this is the timing. The average value, if you focus on it, it is hovering around 142 and above. Now what I can do is, I'm going in the reverse order of the demo. So I have my publisher cable. which is this one. I will pull it out of the switch. So you can see that the BNET detects, basically what it detects is it detects missed packets for the second where I pulled it out from 2982 till the end. It has missed, and then it has missed a complete second, 2 complete seconds of data. After that, it records this as a stream stop event. So that's a setting. You can decide how many seconds you want the BNET to wait before declaring that the stream has stopped. Now I'm going to plug this publisher cable directly into, okay, I plugged it in loopback, and we should see this recover now. All right, so it has recovered. This is the stream status event. You can see here. Uh, this is the time at 15:55:37. There are two events. One is the stream has started again, and it has detected an RMS threshold crossing, which is basically because for the partial second of data, it had calculated some RMS values, and now it is getting the full data, so it is recalculated the correct values. So now I'm getting the packets again, except that it is direct loop back, and you can see the impact is expectedly not too much. It is pretty much 138, 137, whereas earlier it was 142, 145, etc. So that is the impact of this switch. This is just an ordinary desktop switch. It is a VLAN capable switch, but it is not really anywhere near the kind of switches that you'll be using in your substation. So that is why it has a few microseconds of delay, even though it is just a loopback through a single switch. In your real situation in your substation, you might have a slightly more complicated network, so you can still use this method to find out the impact. So I've demonstrated the first use case, admittedly in the reverse order. I intended to do loopback cable first and then connect to the switch and show the increase in the time. Instead of that, I've shown you the switch case first, then looped it back and shown you a slight decrease in the time. But the demo still holds. Also, please note that we are subscribing to 9-2 LE is the one I've selected here. That's why you see these values. If I select the other one, 61869, you can see there are much more. Of course, here I've not set up any values, so they are still 0. But you can see that all 24 channels of information is being received. So I'm simultaneously publishing and subscribing to a 9-2 LE stream as well as a 61869 LE stream. Which brings me to the conclusion of the first part of this demonstration. Let me just, oh, okay, so these are the two use cases, and obviously when we went through the switch, it was as long as the switch is VLAN capable, if there was a misconfiguration between the publisher and the subscriber, you would notice it in the BNET. So we can say that the VLAN configuration has also been validated in this use case. Now for the second setup, we are going to demonstrate scanning. So here I'm going to use two BNETs, where one BNET has no configuration loaded. It's going to just sniff and capture the packets and continue to monitor them just like you saw earlier, while the other one will be used like we did just now with the configuration so that it can publish. I have a slight difference from this slide in my setup. Uh, in the previous edition of this webinar a couple of weeks ago, delivered by my colleague in the US, in the American time zone, he used two laptops, both of them connected through a management network to two different VNets, where laptop A is connected to one and laptop B is connected to the other, and the ports connected on the process bus. But here, the setup I'm using is slightly different in the sense that I'm just using a single laptop, and I thought I'd show you two BNETs connected to two instances of the test set running on the same laptop. So I'm going to do this now. Uh, so I will continue to use this BNET as my publisher. Okay. So the BNET that I'm connected to now, I can stop the subscription, and my publisher continues to run. And what I'm going to do is I'm going to launch one more test set. I thought this would be a more interesting use case rather than having two different machines, to show you that you could do all of this on the same machine. So now I have another test set, and I'm going to use this to scan. Uh, I'm going to use the client mode itself. You will notice that in client mode, you still have the option for monitoring assembly. You just don't have the option to publish, because if you want to publish, you have to be an IED. You have to load an IED in the server mode to be able to publish. But you can still monitor, and you can scan for uh, sampled values. So what I'm going to do is, before that, I need to connect this to the BNET. This is the reason I had disabled the scan, find, and automatic connect, because I want to connect to a different BNET. I don't want to connect to 3.121. I have another BNET which is still hopefully connected to the network. So 1.122. So we will connect to that. Okay. So you can see this is a different BNET. I have actually connected on port A. I'm using this as the management port on the BNET. And here I have the IP address set as 122, whereas earlier in the other BNET I have 1.121, 2.121. I'm going to use B as my subscriber. Naturally, you don't have the option to publish, so you don't see the other option here. So I'll just set it up to subscribe, and my time. So here uh, we are going to see a difference, because even though the time is set, these are two different BNETs, and they are not really synchronized. I mean, computer synchronization is not a very good mechanism. You really need both these BNETs to be synchronized on PTP, which will give you the clock's resolution of up to a microsecond, better than a microsecond actually. But right now this will be hundreds of milliseconds off, so it's not going to be a very good example of timing. But we can still use this for our demonstration, where we are just going to try and catch the stream from the network. So I'm going to subscribe on B, so I don't have to make any changes here. And when it comes to scan, in client mode, there is one more property. It's already set. The default scan, because we already have the option to scan for IEDs as well. That is the discovery mode in client, where you want to capture IEDs, you locate and detect IEDs and load their configuration automatically. But right now I'm interested in SVs. So it's already set. So all I need to do is in client mode, I have to connect it to the process bus, make sure my subscriber port for sample values is connected to the process bus, and then click on the scan button. And it won't detect anything because I have not connected. I'm still connected in loopback on the first BNET. So let me connect the publisher of the first BNET, which was port A, and I will connect this to port B of the second BNET. Okay, I think my lights are flashing. Now let me try the scan. Yes, as you can see. So just to be clear, this is a different test set instance running in client mode connected to another BNET where there's no SCL loaded. I just scanned, just detected the two streams. This is the information just from the stream. I can simply check these boxes and say finish and load this, but I wanted to show you some of the options. If you click on this, it shows you information like what is the number of channels. Now please note that BNET does not know how many of these are currents and how many of these are voltages, because this information is simply not in the packet. So if you want to accurately represent the data, you would need to modify these values. So for example, if you have 8 and 10, for example, or 8 and 8 or something like that, you need to modify them. BNET knows how many channels are in the packet. So this value is fixed. So it says there are 24 channels, but you can reconfigure the distribution. BNET just takes a simple guess and says half of them are currents, half of them are voltages. That's all it does. Okay, so this is one thing you may need to do uh, to if you know how many are voltages and how many are currents. But otherwise, we are good to go. You might also notice that BNET is going to create an IED. It's going to create an IED with this name, with a logical device with this name, and a data set with this name. So you can choose to use the same names for the second one if you want. In that case, what will happen is you'll have one IED with two logical devices and two sampled value controllers. So you can mix and match any way you want. I'm not going to modify any of this right now. This looks good. So I'm going to select both of this. I think my window is showing the other one. Okay, all right. The other window popped up in the background. So I just check both of this and I say finish. And as you can see, what it does is it creates these IEDs. So it creates the SCL, loads them automatically, and it saves them so that you can actually use this later even to publish the same value. So now we follow the same mechanism that we did earlier. We just expand this information, drag and drop it into the monitor, and we are ready to go. So now we select both of this and start monitoring and escort the packets. So as you can see, there is the stream status event that it has started, but we are seeing missed packets being detected, and that is mainly because we have a very obscene value of delay here. So this is what I said earlier, that we ideally need a grandmaster clock in the network, and both of these VNets should be synchronized together. The mechanism to set the BNET time from the computer cannot give you a good result here. So with that done, I think we are done with the demonstration. As you see, we have scanned, detected, and started monitoring those networks. And if this was a real network, you'd be seeing real data here uh, with the real RMS values. So as you can see here, because of the missed packets, there are some changes happening in the RMS values. But this would be in the real case where you have a synchronized network and your subscriber is synchronized to the publisher, you'll not be seeing these issues. So with this, we are done with the demonstration, and I think we can go back to the presentation. So if you understand what I did not use two different machines. I used a server and a client in the same laptop to publish through two different BNETs, publish through one BNET and subscribe through the other. So with that, we are done. And now I think we can look at any discussions, any questions.
Yes, thank you so much, Vinu, for the session and demonstration. We have a few questions from the attendees. One is with regards to 61869. Does the AS6 I61869 support include multiple ASDUs?
Ah, so right now, no. Right now, this supports the number of ASDU set as 1. So we support 61869 with variable data sets with up to the max of 24 channels. But we do not support number of ASDU more than 1, because that is something that is a work in progress, and you can expect that in our next release.
All right, great. Uh, Another question with regards to BNET, how many streams can the BNET device publish or subscribe?
Yeah, as committed earlier, right now we are committing to 4 streams. You can have up to 4 streams publish and subscribe using the BNET, and that has not changed with the introduction of 61869. It's still the same.
Understood. Okay. Okay, there's a couple of questions. Can you run multiple instances of server model itself in the same machine? Uh, Different from this demo where you are running an instance as a server and another as a client. So is that the possibility?
Right, right. Yeah. So that is definitely doable. In most of our demos, we tend to show one instance as server where we load the SCD and all the IEDs from the SCD, and then we run another instance as a client where we connect to those IEDs to
Hmm.
send control commands and enable reports, etc. But that is just how the demo goes. But you can always run multiple instances of the test set in server mode itself. Uh, it auto Normally, the limitation to that is the IP address clash when you run multiple servers. But as you can see, we are already running multiple servers in the same instance. And how we do that is by using alias IPs. So in this demo, I am not using IP address at all. I'm using an L2 network. Sample values only require L2. They don't require L3. They don't require an IP address. But
Mhm.
normally, when we load an SCD file, for every IED, we have to configure an alias IP in our network. So as long as you have multiple alias IPs, you can run a bunch of IEDs on one server, launch another instance, run a bunch of IEDs on that one. So you can have any number of clients and any number of servers or even any number of monitors. So there's no limitation on that.
All right, right. This question just come in. Can this tool read multiple samples in a single packet?
That is, I think, the same question as the first one. I think when you say
Mhm.
multiple samples in the same packet, maybe you're referring to number of ASDU more than one, which,
Mm.
as I said, we do not right now. So we'll be doing more. When you say different samples in the same packet, I can't interpret it in any other way. I think it's exactly the same question.
Sure, sure. Yeah. So if there's, I think, anything more that you may need, I'll just check with the question itself on the person itself, and we'll try to address that.
Yeah, we can do that.
All right. Let me just check if there are any further questions.
I
Yes.
see
So
one.
yeah. So just one question that has come again. Does the BNet firmware tab notify about any newer versions?
In a way, yes. When you install the test set, it comes with the latest version of the BNET firmware, which may be different from the version of the firmware running in your current BNET. So when you connect to the BNET, we always do a check. Whenever we connect, the first time we connect to the BNET, we always refresh all these properties. So it automatically checks and finds the firmware, finds out its date and timestamp. And if this is different, it will ask you essentially, there will be a message here at the bottom saying BNET update, and when you come to the BNET it will ask you to upgrade, and you just need to click a button because the test set already has the latest firmware, so you don't even need to browse for it.
Mhm.
So there are 2 ways you can do it. You can always download a new firmware that ASC publishes on its website, and then you can manually go and browse, load it, and apply. Or if your if your test set is new and has a newer version, it will automatically prompt you to apply. So you just have to click the button and load the new firmware.
All right. All right. Yeah, just one more last question. What is the maximum sample rate supported? Samples per cycle.
So we have tested it up to 44,800 per second. Uh, it will support a bit more, but I think for the what you're referring to, what the questioner may be referring to is the larger sample rates with 61869 were typically you run them with number of ASDU more than one. So which would be supported. When we do number of ASDU more than one, we essentially reduce the time criticality because instead of doing 4,800 transmissions in a second, you might have double of that, 9,600 uh, samples, but you send them two at a time. So that again resolves to 4,800 in a second. So the
Mm.
typical way to do this, like 14.4 kilo sampling rate, the higher sampling rates is to use two or four number of ASDU. So that would normally be supported. But yes, for that you have to wait for the support for the number of ASDU more than one, which is what we are working on right now for our next release.
Got it. Got it. Great. I think we have covered all the questions. Of course, if there are more, if you have any more any queries, please feel free to message me or mail us on the same email that we had shared for the discussion. So that should be fine. I'm just looking at if there are any further questions. No, I think we are good, Vino.
All
So
right,
thank you.
sounds good. Thank you very
Yeah.
much, folks. Thank you for attending this webinar and look forward to talking to you all again at some future date.
Thanks everyone and have a good day.